Today we'll be discussing the maintenance of external load systems for helicopters. And this picture is a good example because we can see the components of what I mean by an external load system. The hook in the rigger's hand is part of what we call remote equipment. Remote equipment is jettisonable from the helicopter and has no FAA requirements. That hook, the remote hook, could be connected to a swivel, which would allow the hook to rotate and not twist up the long line that's above it. The long line goes to a belly cargo hook, which is attached to the helicopter and has FAA requirements. It must be approved either as part of the type certificate from the manufacturer of the helicopter or a supplemental type certificate from a company like Onboard or the other cargo hook manufacturers that are out there. Though there also may be a weighing system. A weighing system shows the pilot how much weight is hanging on the belly hook. So in this case, it would include the remote hook and the line. And then there's the controls inside the helicopter for the hook. The belly hook has to be able to open two different ways. That's commonly referred to as the fixed provisions, and we'll get into that as well. Our presentation today will into take the external cargo system from three points of view. There's the maintainer, the operator, who in my case, I use the pilot as the operator, and then the owner. And I know this is a maintenance presentation, but many times smaller organizations, one person plays all three of those roles, or at least two of them. And as a maintainer, you want to make sure that the operator is operating the aircraft in accordance, it's airworthy. So, and within the requirements of the flight manual supplement, and then to help advise the owner if the maintainer is not the owner, what maintenance requirements are required for things like contracts with load tracking, how much weight was on the hook, when it was on the hook, when did I get rid of the weight, which is requirement for Forest Service contracts now. And then one of the recent developments over the last 5 years are the new rules for human external cargo, whether you're carrying power line workers, as shown in this picture, or people up to a remote site, then human external cargo carries other requirements that the non-human cargo doesn't. So Onboard Systems is a manufacturer of all the equipment we talked about. The remote equipment, we manufacture some. There's a very, very wide variety of what could be considered remote equipment. But that's all we do is external load equipment. We supply equipment directly to the Airbus, the helicopter manufacturers. We make the hooks, the weighing systems we talked about, which is how the hook, or the suspension system, which is how the hook attaches to the helicopter. And we're part of an ownership organization called Signia Aerospace, which is our holding company. And within our division of Signia, we have Meeker Aviation, which are mounts to have for a LiDAR or a camera system, life saving systems, which is equipment for mostly water rescue. And then the newest division, the Onboard Systems Hoist and Winch Division, which was formerly the Collins Goodrich Hoist and Winch Division, are now part of Onboard Systems. So the presentation that we do next year may include all that equipment as well. So here's what I referred to in the first picture. So the cargo hook is mounted on the belly of the helicopter and is a certified piece of equipment. And it can be accompanied by a weighing system, which conveys the weight to the pilot. The suspension system is just how the hook attaches to the helicopter. There are some fairly simple systems and some very complex systems depending on how the manufacturer designs the aircraft and where the hard points are to lift the cargo. There under fixed provisions, you see one of the controls, the backup control for the cargo hook. And then that indicator is used in a weighing system, the device on the left, to show the weight to the pilot that's being currently carried on the hook. And then the remote equipment hangs from the belly hook. And you can see in just that picture there, it could be a wide variety of equipment. In addition to the cargo equipment, there's things like fertilizer spreaders or fire buckets that hang from the cargo hook as remote equipment. There's harnesses sometimes for lifting animals or fertilizer, like I said, fertilizer spreaders or equipment to cut trees, the saw that you see a lot of times, trimming trees on power lines or topping trees. All that falls into the remote equipment. So there really is no way to talk about maintenance of remote equipment, but we'll cover it a little bit. It basically means follow the manufacturer's guidelines that they supply that you get with when you supply the equipment. One term that may come up in the discussion is the difference between a keepered or a keeperless hook. So keepered hook is the one shown on the left and in the middle. It has that spring-loaded gate which moves out of the way as you load the cargo hook. And usually every keepered hook will have a warning like you see in the middle that if you use a ring that's too big, it can actually slip off the hook without opening the hook. And that's a big issue on remote hooks as well. If the ring size is too big, and in a lot of Forest Service contracts, the ring supplied is too big for some remote hooks, that it'll fall off. You'll also see up at the top a warning about cable rigging. We'll get into that a little bit later. But if the hook uses a mechanical cable as the backup release, you need to make sure the distance between that ball on the right and the fork is set at 1/8 of an inch. Because if it's too close, bumping the lever might open the hook inadvertently. And if it's too far, when you pull the handle, the ball won't push the fork open, which could mean not being able to jettison the load, which in a lot of ways is definitely more dangerous than just dropping a piece of equipment. On the right, you see a keepered hook. On the keepered hook, that front piece, there is no keeper, does not open. The hook just opens on its own. Not, excuse me, not on its own, but it'll open and then has to be open to be loaded. The following section comes from one of the manufacturers of keepered cargo hooks. Because the keepered hook closes after the load is released, there is a spring that has to be overcome. So if there's very lightweight rigging, say a synthetic line that doesn't weigh the 15 or 20 pounds needed to pull the hook open, then pressing the button, the hook will not open. So then what the pilot has to do is you see here, he or she sets up essentially a tug of war with the load on the ground. So the pilot will have to increase collective pitch to pull the hook open while they're pressing the cargo release button. Keeperless hooks, the load beam opens under its own weight. So in a brownout or a whiteout condition, that can be a lot easier than having to do this operation where you're using the helicopter to pull the hook open in an unsafe condition. So now we'll focus really on the issues the maintainer, the person who's actually going to maintain the cargo hook will face. And just curiously, again, in this picture, you can see the Bambi bucket, which is a remote equipment. And on the front of the helicopter is the kind of mounts that Meeker in our group makes, as well as the mount that holds that spotlight at the back. And so, if that's of any interest in the future, we can add maintenance of that equipment to our presentation. So, this is a bit of an eye chart as well. It comes from Onboard's component maintenance manuals. Now, Onboard is not the only company that makes cargo hooks, but a lot of us have the same or similar information on the maintenance of the hooks. They play the same role. So, in Onboard is recommended that experienced aircraft maintenance facilities can maintain the hook. So, in live presentations, I'll often ask anyone in the audience if anybody works in an inexperienced aircraft maintenance facility. So if you're attending this meeting today, I'm sure you work for an experienced aircraft maintenance facility. So that's generally not the biggest hurdle to overcome to be able to overhaul the cargo hooks. It's the last underlying part there. The equipment to acceptance test the cargo hook. Basically, after you take the hook apart and put it back together, you have to load it with a load much higher than the you do with the aircraft, because the hook is rated to much higher than that as a safety margin. So at Onboard, we do it with the hydraulic presses. Some people will have known loads, concrete blocks that they lift. You could use the pneumatic system. But if you don't have that machinery or a way to load the hook, then you won't be able to fully maintain or overhaul the cargo hook. So who and where are kind of the same question, but if you have the equipment, you could do the cargo hook maintenance yourself, uh, or whoever owns the hook. If you're operating a leased equipment, that the person you're leasing it from may have the equipment to do the acceptance test of the hook. There are third party maintenance facilities out there, not as many as you would find in things like engines, but there are third parties who do maintenance, especially if you're located far away from the United States and you don't want to send your hook halfway around the world to have maintenance done. You can return it to the helicopter OEM. Usually, though, they don't have the equipment and they would probably end up sending it back to us. And then, as the manufacturer, Onboard is authorized to maintain any of its equipment. So the next question in the who, when, why list of questions is, when does it have to be overhauled or maintained? So the most important thing is always that you follow what's in the component maintenance manual for the equipment you're looking at. So we will not get into all the details of the maintenance of the cargo hook in this presentation, but this information will be contained from Onboard in any component maintenance manual you get with any of our equipment. And for the other things besides the hook, we put it in an ICA, the instructions for continued airworthiness. So the cargo hook leads somewhat of a tough life. It's outdoors all the time. It's dragged sometimes through bad weather, high speeds, and cold and hot days. So monthly, it's really just a cleaning that should be done, and any sort of corrosion prevention. Usually, if you're in one of those environments where corrosion creates a problem. And the maintenance CMM has some suggestions on which, the kinds of maintenance of corrosion prevention that can be done annually or 100 hook hours. I want to emphasize here that hook hours and flight hours are not the same thing. You can treat them the same way, but you'll be maintaining your hook much more often than you need to, because most of the time you're not doing external load continuously that you're in flight. So that is one of the requirements of onboard hooks, is that you keep track of your hook hours. So a lot of times people will run into their calendar requirement before the hook hours, so they know they'll never reach the 1,000 or the 1,500 in the 6 years. But there will be, if you are coming up against that, you will need to track the hook hours for your maintenance calculations. And then so with 1 year or the 100 hook hours, basically you'll just remove the hook from the suspension, and then the hook always hangs from an attach bolt. And it's always good to clean that and lubricate that so that the hook can swivel or pivot as necessary on that bolt. And then depending on which system you have from onboard, it'll either be the 5 or 6 years and or 1,000 or 1,500 hook hours you'll need to do an overhaul. So this is always a question that it's hard to answer and really will rely on your best judgment. We basically say you should start tracking when the hook is installed on the aircraft for use. Now, if you get the brand new aircraft from a manufacturer, uh, when you go out to use it for the first time, you could start your count. And then if you get an aircraft and you don't know how many hours on it, you can either estimate that or have an overhaul done, or have the person selling the aircraft do an overhaul, so you can be sure that you have an airworthy hook. And then the acceptance test, which is again detailed in our CMMs, is required anytime you do maintenance where the side plates are separated. So anytime you're taking the hook apart, it will be necessary to conduct this acceptance test. And that's the test that requires the loading of the much higher weight than the hook is rated for, and the equipment that most places won't have. Like we talked about earlier, the most important thing is to ensure that you do have the current documentation. And Onboard has a system, like many of the manufacturers, that will notify you whenever there's an update to any of our documents or manuals. So if you do have a inspection from the FAA or any civil aviation authority around the globe, you can show that you're signed up for the onboard systems and that you're getting notified of whenever a new manual or document comes out. So again, this is a very abbreviated version what's in the component maintenance manual. But an overhaul of the hook will consist of basically disassembling it. You'll have to inspect those disassembled parts. Some will be easier just to throw out than inspect: fasteners, springs, things like that. Uh, s- some of the equipment does require non-destructive testing, some doesn't. Some of the cargo hooks do have a life on the hooks themselves, so you'll need to make sure that you're not coming up against any of the life limited parts. You'll have to have the required replacement parts, which for most of the hooks, there is no required replacement. But anytime you find something that is damaged or gouged or a hole that the bushing is wearing out and you're starting to see an oblong shape, that's when you would need to replace those parts. Then simply reassembling. It's an electromechanical device, relatively simple compared to a lot of other things that are on the helicopter. Then running the acceptance test will be the biggest thing, like, that you may not be able to do, and then do a final inspection and a return to service tag. So the acceptance test procedure is detailed again in the CMM, but basically you want to look for electrical resistance through the hook. The hook uses a rotary solenoid, and there will need to be continuity through that cycle. You have to make sure the hook functions with no load on it, and then you'll have to apply what's called the limit load, which is 2.5 times the hook design load. Now, you may be operating a helicopter that only lifts 800 pounds or 1,500 pounds, but the cargo hook is designed to lift 3,000 pounds, which is what some of the smaller onboard hooks lift. So you'll have to find, again, a way of loading the hook to 2.5 times that 3,000 pounds. One maintenance tip that comes up from time to time: inside the hook, there's a diode that works to control the flow of the air of electricity from the cargo hook. Some of the older onboard cargo hooks and some that we still deliver today are polarity sensitive. So if they're hooked up the wrong way, you can destroy that diode. So when you do have a cargo hook that won't open electrically, uh, again, the following information is in the CMM. You'll just want to check the resistance across the two pins that operate the cargo hook. Some of the hooks will have extra pins if there's a switch or something in there, but the two hooks that drive the solenoid, getting infinite resistance, you'll either have a bad diode or a bad solenoid. If you do get infinite resistance, you'll want to separate that diode from the solenoid and measure each. And it could be a big difference of only needing a very lightweight, easy to ship diode, as opposed to sending in the hook to onboard for evaluation, or getting a more expensive, a little bit more to ship solenoid sent out to you. Now we'll switch from the cargo hook to some of the fixed provisions. So the FAA in general and most civil aviation authorities will require a primary and a backup system for the cargo hook. The primary is usually an electric switch on the cyclic or collective. And we won't talk much about that today because those are relatively easy to understand main, and maintain equipment. One of the systems that Onboard uses in a lot of our newer and almost all our new kits will only have a hydraulic option. So this is the master cylinder. In the picture on the right, you can see it mounted to a collective. And on the onboard kits, one of the things, the master cylinders are like the brakes on a motorcycle, or even the brakes on your car. That if air gets in the system, that the system can feel spongy, or it won't work. You'll pull the lever and it won't pull the hook open. Just like we talked about mechanical cable, if that rigging is not set correctly, up when you operate that handle, it won't open. So on the onboard kit, you can see that green band shown on the bar leading into the master cylinder itself, which is, again, it's just a small reservoir of hydraulic fluid, like the brakes on a motorcycle. So when you pull that lever to full travel, some of that green band must still be visible. If you have air in the system, the band will completely disappear. And at that time, you'll need to bleed the system. And again, those instructions will be shown because it's not the cargo hook, it'll be the ICA, the instructions for continued airworthiness before the next cargo mission. Because again, the jettisoning from the belly is usually only done in an emergency. And so the pilot wants to make sure when that handle, if they need that, again, the backup, for some reason, the electric doesn't work and that backup system is needed, you want to make sure that it's going to open the hook. So the other way that many cargo hooks open is a mechanical cable. There's a third I won't talk about here. It's a dual electric hook, and that's only for larger aircraft that have two independent electric systems. So here you can see four different styles of mechanical release cables, and then one that's actually a foot cable on the Bell Medium. And some of the older Sikorsky helicopters will have a kick pedal as the backup. And many times the primary is on the cyclic and the backup is on the collective, as shown on the picture on the left. But sometimes the backup is not on the flight control itself. The T handle in the top picture, as you can see, is right next to the collective, but it's not on the collective. Or in the case in the bottom right, both the primary and the backup are on the cyclic. Mechanical systems also have failure mode. So when you're doing a pre-flight inspection, you want to, or an annual or return to service, you will just want to look for excess friction in that handle that really should pull smoothly. This now is like the brakes on a children's bike as opposed to a motorcycle. And then you can see some of the cable both inside the helicopter and outside it to look for any visible kinks in the cable that would restrict the cable flow and prevent it from opening. So here's real pictures from the fields where you can see that the covering on the mechanical cable is starting to wear. So that wear can let moisture in, you could get corrosion, or that wear could continue and wear the cables themselves. So this would be a good example of cables that should be replaced. The other challenge with the mechanical cable like this is most of the time they're inside some sort of sheathing or covering. So the picture on the left, you can see it looks like it's kinked, but there's no visible damage. But when that rubber collar is removed, you can see that the sheathing has broken, and then that hook now might have more travel and able to move further than the cable would normally go. And that extra flexibility in the cable, the extra room, could lead to an inadvertent release if the hook moves to its full travel opposite that cable. So again, on pre-flights or the annuals or anytime you're doing maintenance, following that as much of that cable as you can see is important. The other fixed provision, and there's one on the removal side too, is the weighing system. Not every aircraft has a weighing system. Some manufacturers always include it with their external cargo system when they deliver an aircraft with a cargo hook. Some feel it's something that some operators want to put it on. Some so some like the R22, at least from an onboard, it's a 12-volt system. So all our weighing systems are 28-volt. So there would be no option for equipment like that. So again, the weighing system will basically tell the pilot how much weight is on the cargo hook. There are always three major components to a weighing system. There's the load cell itself, which is the link that attaches the hook to the aircraft, and that either can be a true link with the attach point on bottom and then on the top, or some of the newer kits we make, it's a pin load cell that replaces the attach bolt that attaches the hook to the helicopter. Then that's connected to a cable, which the harness, cable to the harness, which leads the indicator, which is the device, the two devices shown in the picture are onboard indicators. Again, Onboard's not the only company that makes weighing systems, but a lot of the principles are similar. You'll have some unit that displays the weight, and there might be other functions in that device that change brightness or change from kilograms to pounds where you are in in the world. There'll be Most indicators have some sort of error message. So when you're troubleshooting the system, if you've got an error message, that's pretty clear that you're going to have some problem. To use that indicator, uh, record that error message. If you have two different indicators, you can switch one out for the other. There's some basic continuity checks that you can do. And then in the picture above, you see a loadway simulator. It's a device that mimics the load cell, because if you're getting a bad message, like you can see here, it can either be the load cell that's bad, or the indicator that's bad, or the harness between them that's bad. So, and most of this equipment, the fixed provisions at least is on condition. If the indicator is working, you can go ahead and use it. And then the load cell will have a calibration cycle, the same as the hook. But in Onboard's case, the load cell could only be sent back here to Onboard for recalibration. So now the other thing that comes up from time to time is, well, if you have a heavy cargo hook, you might want to take it off the helicopter if you know you're not going to be doing external load for any sort of time. Some, like shown in the picture, are not, they don't hang that far below the aircraft, so it may not be as important. Or what you'll find that maybe you have uh, three helicopters with fixed provisions, but only two sets are removable. So you'll need to take one set of removable off and then store it while another helicopter comes in to attach it. So in the onboard CMMs, there are storage instructions as well. And this is just a summary. If you get the hook from the factory in one of our STCs, it's shipped in our packaging and everything. You can store it for 2 years on the shelf. If a contract failed to materialize or whatever went wrong, if it's more than 2 years, then there'll be some testing required. If you do install it and then take it off, if you've got a dry indoor temperature controlled environment for 6 months or less, then it's okay to use. And again, a logical step if you are in a corrosive environment, before you store that, take some extra steps for corrosive ingredients. And then the big point here, the same kind of things we talked about, but if it's unknown storage and even less than 5 years, you want to test it as well. So kind of the last of our W's is why do the cargo hooks need to be overhauled? Well, number one, they are sometimes carrying very expensive cargo, uh, and that can include people if you're doing human external cargo. It is the lubricants inside it do dry out over time. I know there's newer and newer improvements in greases and lubricants that allow them to last longer, but it, like I said, the hook does live in a tough environment, in outdoor, hot, cold. You might have some rain or other condensation that gets on it if anything drips off the belly. So it can be relatively, nothing in aviation is inexpensive, but compared to a cargo hook system, an overhaul every 5 or 6 years is some relatively cheap insurance that you're doing all you can to keep the cargo hook airworthy. The next component we'll talk about is the suspension system. And as this picture shows, there are numerous different ways the manufacturers have come up with attaching cargo hooks to the aircraft. Some will hang from four cables on a frame and almost just be a few inches above the skids, or 6 inches above the skids. Some are flatter cabled systems. Some make a very flat frame across the belly and pick up at either 2 or 4 or 3 points, or one, the bell medium on the far right will actually go up into the helicopter. The skin of the helicopter is halfway up that black bumper ring. So it'll be impossible to really give guidance on maintenance on each one of those systems with all the different components. But I went through a lot of our uh, ICAs, our instructions for continued airworthiness, and pulled out some of the following general things that you'd be looking for when you're maintaining a suspension system. Top one again, always you have the current documentation, and in the in the ICA you'll see things like any sort of bearing wear. So if it's a solid bearing and it's a bronze bushing and you start to see the bronze wearing away, that'll be time to replace that bushing or bearing. Any nicks, scratches, damages, the ICA will give you guidance on what's too too deep a gouge, or one that, or if you can buff it out or smooth it out. Certainly, any of the rotating surfaces, you're looking for wear there. Cracks, some are visual, some will have to be done with non-destructive testing to look for cracks. Uh, Diameters of rotating parts, non-round holes. Once the over time, any sort of wear will make that perfectly round circle start to take on an egg shape, and you want to make sure that you wear the bushing and not the actual part. Things like placards, to make sure they're missing. Make sure, if they are missing, make sure you get a replacement. You have that information, and then, like the cargo hook, lubricate as necessary. Each of those, a lot of those systems move around themselves. Some of the hooks are attached at a single point to the belly, but look for all the lubricate again as called out in the ICA. I talked about this when we started. Remote equipment is incredibly variety of what gets slung underneath helicopters. It's anything you can think of. Sometimes there's single hook systems, there's multiple hook systems, there's ropes of synthetic materials, steel cables, saws, fertilizer buckets, the any I just saw a system recently where instead of pulling wire from the ground, you suspend the spool of cable underneath the helicopter if you don't have a place to put the spool on the ground. So you have that. Like I said, we have pictures of rhinoceroses being lifted out in Africa to be taken to mate to the veterinarians, or horse falls through the ice, all those kind of things. So really the best practice would be to follow the manufacturer's documentation. However, because all this equipment is not covered under any supplemental type certificate or any type certificate, you're not obligated to follow that. They there's no FAA requirement that only this person or that person can maintain the equipment. However, a lot of times if something goes wrong, it's always easy to point that, hey, you've done everything the manufacturer required. And if the equipment goes wrong, then at least you can say you've done everything you could do to keep that a safe and airworthy operation. And then here's just a snapshot from our website is the document update service onboard offers. So if you sign up and put your equipment in there, either we can email you or even fax you a notice that says this document has been updated, a service bulletin came out on this equipment, a service information letter, we've revised this, anything that changes, you can use that service. And then there's a video tutorial on how to do that. So now we'll take a look at the things the owner of the helicopter that affects the owner, how the cargo hook external load system affects the owner. And some of it again is ties into maintenance as well. So this came up most recently in fire contracts, where we'll see on the next slide that the Forest Service is requiring that operators report where they pick up water, how much water they pick up, where they drop it, and the altitude, things along those lines. So many of the requirements onboard can't do, but the quantity of what you're lifting, the water, there is an output from either of our indicators. You can see the top is the older C39 and the bottom is the our newer indicator that can transmit the data where it can be collected and then sent to the end user, which in the case is the Forest Service, or if you're not on Forest Service contract, it can be just sent to uh, a home base or anything like that. Here's an older RFP, but here's the stuff that the Forest Service will need you to track. So you can probably find this actual RFP online, or it's in all the new ones too. Actuation of the bucket, open, close, drop, and then it has to connect to this what they call the ATU, which ultimately requires transmission of the data to the Forest Service every couple of minutes. And so I've summarized it here from what you've seen. 2 minutes from the time of the event, it has to be in the Forest Service system. Now, that's a lot more complicated. Sometimes you want the data for your own use. If you're billing a client for the weight moved, it's nice to have evidence. And there are systems out there as well that do that. And they all rely on collecting data from the C39 or the C40. And Onboard used to manufacture what was called a C20 or a C30 data loggers, but unfortunately they're obsolete. And this is an output from a tracking company system. You can see it's all in kilograms, but all that can be converted as well. So for human external cargo, one of the biggest changes that came out is that your rotorcraft flight manual supplement, RFMS, must now specifically approve external cargo. In the past, it was one the manual doesn't say I can't do external cargo. So within the last 5 years or so, this became a requirement. And here are three different examples of STC kits and some type certificate kits on examples of how that's shown in the flight manual supplement. And the last question that comes up sometimes is fleet management. I have 10 helicopters. Can I move the hook from, my Bell 407 to my Robinson 44 to my AS350 to my MD 500 to my Leonardo 109 to my Enstrom? Sometimes that's possible, but a lot of them have different part numbers. Like we talked about, some might be mechanically operated, some are cable operated. And then even some of the mechanical hooks might have different fittings, the mechanical fittings that are on there. And then not every hook is certified for every helicopter. So the simple answer to that, of course, I shouldn't say, of course, the simple answer is just give us a call, tell us what you have, and then we can direct you. If you move from one hook to the other, you might have to get a whole new set of flight manual supplements and ICAs for that hook in that kit. So the last what we'll talk about is the operator, who in the case we're talking about here is the pilot. So for a pre-flight, the cargo hook has a pre-flight requirements, and this is the FAA regulations that require the pilot become familiar with all information concerning that flight. And sometimes getting the information on the cargo hook can be in multiple different systems, multiple different documents. Sometimes the manufacturer, so in this case, Bell's flight manual won't have cargo hook information in it. So then you'll have to get a Bell flight manual supplement that goes with it. But if you use an STC, an onboard STC, you might need the Bell flight manual, their supplement, and then an onboard flight manual supplement. For instance, if you add a weighing system to an aircraft, or you had an older hook and you changed the hook, you'll have a flight manual supplement for that newer hook and the new weighing system. And then some cases you might have the the Bell, or not Bell, but any basic flight manual, and then a onboard or other STCs supplement. So the pre-flight is fairly simple. You want to make sure the cargo, look for obvious damage. Obviously, the pilots are not maintenance. The A&P mechanics or maintenance technicians. If you want to make sure the hook can move through its full range of motion, and the cables or the hydraulic line, electrical harness, or mechanical release cable don't you don't are not what prevents the hook from reaching the full its full range of travel. All hooks will have some other way that stop its motion well before those cables are stretched. And then you want to use actuate the hook. So the PQRSS is the FAA's term for the primary quick release subsystem. So you'll have to give power to the aircraft, make sure the electric button causes the hook to open or release, and the backup opens and release. And a lot of the cargo hooks will also have a ground release lever on the hook itself. So those three things, the pilot obviously wouldn't operate the, the ground release lever. So the pilot's view of the cargo hook is very obscure. There may be an arming system that turns the hook on or energized system, the cargo release buttons, and then there's the example of the kick pedal. And this is one of the challenges as an pilot and an operator too, that all these ways to operate the hook are in different places. I liken it a lot to if you drive a German car, but then you go rent a Japanese car somewhere. You think you're making a turn, but then you turn the windshield wipers on. So it'll be important to make sure the pilot's aware of where each of these backup systems are in comparison to uh, the aircraft he or she may have flown yesterday. If you have different manufacturers in the fleet, and then what will happen a lot of times is there will be some rotorcraft flight manual changes if you're doing external cargo. So the never exceed speed will usually go down with external cargo. You want to make sure that the whatever you're carrying doesn't the line doesn't go up into the tail rotor. Sometimes you'll see gross weight increase because the weight is either not on the skids or is at the center of gravity. Uh, they may give you some manuals will give you a wider CG limit again because the primary load will be at the center of gravity. You generally can't carry passengers when you're doing external cargo. Then there'll also be added emergency procedures now in a fire or auto rotation, engine out, things like that. You have to deal with if you have cargo on the line. And then there'll usually be additional placards in the aircraft related to the cargo system. Obviously, what buttons control what's on, information about the weighing system. So those are the things as a pilot they may see from one to the other. And then as a maintenance professional, understanding all this will help understand the everything that goes into the cargo hook system. So that concludes the presentation today. I realize you can't ask any questions in the presentation, but there's my information. You can send any questions to me, and I will make sure I get back to you or the right person does. Thank you very much.